So, good afternoon. Uh, Today attendance is pretty low as of now. Only one student has joined. So, anyways, I think we have waited enough. Let's just start. So, let me just give my introduction first. My name is Musab Rafiq. I'm the course TA for the course at Digital Circuits. The course is taught by Professor Shantanu Chattopadhyay from IIT Kharagpur. I am myself from IIT Kanpur. I'm a PhD student in the Department of Electrical Engineering. This is live session number 8. So today's live session we will discuss problems pertaining to week 8 material. This week's problems will mostly cover topics like ADCs, DACs and all. So during the course of live session, if you have any doubts, please let me know. Also, after I solve a particular problem, ample time will be given to the students to asking their doubts. Also, I kept some problems as do yourself exercise, that is they are highlighted in the slides. What I want is that you should try to solve them first. I'll give some time for you guys, and after you solve, you wrote down your answers, I'll show the solution. The live session is being recorded and is uploaded to the YouTube channel, and the link to the YouTube channel as well as the course material has already been provided in the NPTEL portal. So let's start with today's live session. So we'll just move forward to the first question of today's live session, which says that a 8-bit DAC has a step size of 25 millivolt. What will be the full scale output voltage? So the given is we are given a 8-bit DAC that has a step size of 25 millivolts. The question asks us to find out what will be the full scale output voltage. So let's proceed. So let's just write the information available to us first. So it is an 8-bit DAC. DAC stands for digital to analog converter. That implies N is equal to 8, right? And also step size is 25 millivolts. Let's just convert into volts. So it will be 0.025 volts. Units are important, right? So we know that step size is equal to full scale output voltage divided by 2 raised to power n minus 1. So we have this formula with us which says that the step size of a DAC is equal to full scale output voltage divided by 2 raised to power n minus 1, where n is your number of bit DAC, so with precision of the DAC, right? So now we have full scale output voltage that will be equal to step size times 2 raised to power n minus 1. My step size is 0.025 multiplied by 2 raised to power 8 minus 1. So this will be 0.025 multiplied by 256 minus 1. It will be 0.025 multiplied by 255, and this thing, if I'm not wrong, is equal to 36.375, and the answer is in volts. So option A will be the correct answer. So what was the question? The question was we were given an 8-bit DAC that was having a size of 25 millivolts, right? And we were required to find out the full scale output voltage. So what I did, I just wrote n equal to 8 and step size of 25 millivolt I converted into the volts is 0.025 volts, that is SI units. Then we know that step size is equal to full scale output voltage divided by 2 raised to power n minus 1. plugging the values of step size and 2 raised to power 8 minus 1. Ultimately, after the maths, we have 6.3754 as our final answer, right? Any doubts in this question? Please let me know. You can always unmute yourself or write in the chat box, whatever is feasible to you guys. Okay, shall we proceed to the next question? So the next question, as you can see, I've highlighted this. So I request you guys to try to solve it first and type your answers. Only the options, type the options in the chat box. I'll give you 2-3 minutes to solve it. It should not take more than 3 minutes, in fact, and then I'll show you the solution. Even to the people that are in the live recordings, and what I mean here is to the people that are watching the recordings of the live session, they can also pause the video and try to solve it, and then if they have made some mistakes, they can always refer the solution. So in that way, you'll be better versed with these problems rather than solely depending on me. What you can do is you can try by yourself and then solve and then see the solution ultimately. So I'll just read the problem as the roll is quite low, but still I'll ask the students that have joined, please try this. So it states that an 8-bit DAC produces V out equal to 0.05 volt for a digital input of 0000001. What is the full scale output and resolution of DAC respectively? So you need to find out the full scale output and the resolution of DAC. So I request the students that have joined, please try it and type your answers. After that, I'll show the solution. So if you are doing it, please, or if you have done it, you can track the answers. So if you are doing it, okay, so let me show the solution. I'll just read the question once again. It states that an 8-bit DAC produces V out equal to 0.05 volt for a digital input 1. What is the full scale output and resolution of DAC respectively? So given is we have the V out, that is the output voltage. Output voltage is given 0.05 volt for input 0.00000001. So what does this imply? If we are having this input output for this input, this is nothing but step size. Because the input 1 will only move one step. So what is that one step? Is simply your step size, right? So my step size of a DAC is equal to full scale output voltage by 2 raised power n minus 1, and here n is your 8. So n is your 8 right here. So n is your 8. That implies step full scale output voltage is equal to step size times 2 raised power n minus 1. Step size is 0.05. This is 2 raised power 8 minus 1. So this will be 0.05 multiplied by 255, and this thing is equal to 12.75 volt. So your full scale output voltage is 12.75 volt. Now the resolution of DAC. So the resolution of DAC is equal to step size by full scale output voltage. Let me just separate this thing, otherwise people might be confused. So this is step size is 0.05 volt, and my full scale output voltage is this, which I have just found, is 12.75. If you divide this, it comes out to be 0.00392, and when we talk about percentages, we'll just simply multiply it by 100 and we'll get to 0.392%. So my FS so my FSO is equal to 12.75 volts, never forget the units, and my resolution is 0.392%. If I carefully look at this, this is option B. That is my correct answer. So a couple of students joined late, so for their benefit, I'll just repeat again. So the question was, actually this was a do you yourself question, where you guys will have solved it first, and then I would have shown the solution. So as some of you joined late, I'll just repeat it here. Just give me a second, I need something. Yeah. So it says that an 8-bit DAC produces V output of 0.05 volt for the digital input 00000001. What is the full scale output and resolution of DAC respectively? So what I did, I used this information that the V output voltage was equal to 0.05 volt for input 1. That simply means this was the step size. So as we move from 0 to 1, that is the step size it moves, right? So I can simply state that. So output voltage for input 1 is my step size, right? Then step size, according to formula, you might have seen in your lectures as well, is full scale output voltage divided by 2 raised power n minus 1, where n is the bit of how much bit the DAC is. So in the given question, it's an 8-bit DAC. So then full scale output voltage will be equal to step size times 2 raised power n minus 1. So step size will be equal to 0.05, sorry, full scale output voltage will be 0.05 volt multiplied by 2 raised power 8 minus 1, that is 255, times 0.05, that is nothing but 12.75 volts, right? After that, we need to compute resolution. So resolution of a DAC is equal to step size by full scale output voltage. Step size I know that is 0.05. Full scale output voltage I just figured out, and then I plug these values in here, and after doing the division, I got my resolution equal to 0.392%. Actually, resolution was this 0.00392, but in terms of percentages, we have to multiply it by 100 and we get the percentage. And this was your option B. Any doubts, any queries, please let me know. Otherwise, we can proceed to the next question. Just one thing, am I audible? At least confirm that. At least in that way, I can I can confirm at least you guys are listening to the lecture or hearing. Are you guys following? Just confirm that. Hello. Uh, can anyone confirm? Anything? Think, but I think I'm audible and screen is also visible. I think people are not in front of their screens, I guess. Anyways, whenever you see this message, kindly confirm. So let's move to the question number 3 of today's live session. It states that if the resolution of digital to analog converter is approximately 0.4% of its full scale range, then it is. So we need to find out what bit in converter is this. Is it a 12-bit converter, 16-bit converter, 8-bit converter, or 10-bit converter? So we are given this: the resolution of DAC is approximately 0.4% of its full scale output range. First of all, the red slide resolution is equal to your full scale output voltage, right, divided by 2 raised to power n minus 1, and this thing is equal to 0.4% of the full scale output voltage. So let me write here, I use this abbreviation. This is nothing but full scale output voltage. So FSO by 2 raised to power n minus 1 will be equal to 0.4 by 100 into FSO, right? So this and this will go. That implies 2 raised to power n minus 1 is equal to 100 by 0.4. That implies 2 raised to power n minus 1 is equal to 100 by 4 is 25, and this is 250. So that implies 2 raised to power n is equal to 251. That implies n is equal to 8. So this is a 8-bit converter, right? Now let's move forward to question number 4. So what is the output of following circuit for the input B4 is equal to 1, B2, B3 is equal to 0, B2 is equal to 1, B1 equal to 0, for V reference equal to 16 volt. So anyone, what is this circuit? Can anyone identify what is this circuit called? You might have seen this circuit in your session lectures. What is this circuit? Anyone in the audience? I would love to see your responses. But anyways, this is an R to R ladder deck. So in R to R ladder deck, you know that your output voltage is equal to minus Rf by R1 times Vref, then it's bit MSB divided by 2 plus bit MSB minus 1 divided by 2 raised to power 2 plus so on plus bit LSB divided by 2 raised to power n. Here B1 is your MSB and B4 is your LSB, right? That implies, I'll just write here, V out is nothing but minus R by R1 times Vref B1 by 2 plus B2 by 4 plus B3 by 8 plus B4 by 16, and this is minus R by R1 Vref. Your B1 is 0, B2 is 1, so it is 1 by 4 plus 1 by 16. Then plugging values, Rf and R1 are both R, so this will be 1. Vref is your 16. This is 16, then minus 16. Taking 16 as LCM, so this is 4 plus 1. So this is minus 16 times 5 by 16. So this is nothing but minus 5 volts. That is option B. That is the correct answer. Any doubts? Any queries? Please let me know. Any doubts? Anyone? So anyways, now let's move forward to question number this is 5 of today's live session. This states that an 8-bit DAC has a resolution of 20 millivolt per LSB. So the resolution is 20 millivolt. Find the output voltage. So we need to find the output voltage for this input. So given is resolution is equal to 20 millivolt, that is equal to 0.02 volt, and we need to find out the output voltage. So output voltage is equal to resolution times the digital decimal equivalent input. Resolution is 0.02 and decimal equivalent we need to find. So this is simply 0, 1, 2, 3, 4, 5, 6, 7. This is simply 2 raised power 7. This is simply 2 raised power 7. This is simply 2 raised power 7, and 2 raised power 7 is 128. This is 128. So 128 into 0.2, this is 256. Decimal is after 2 digits, so this is 2.56 volt. So the correct answer is option 3. So let me just repeat this question. So question asks us, an 8-bit DAC has a resolution of 20 millivolt per LSB. We need to find the output voltage if the input was 1 1 0 0 0 0 0, that is this. So given here is the resolution. So resolution is 20 millivolt, that is 0.02 volt. Output voltage is simply equal to resolution to decimal equivalent of input. Input is 2 raised power 7, decimal equivalent is 128. So this 128 multiplied by 0.02 will be equal to 2.56 volt. Any queries, any doubts? Shall we proceed to the next question? Anyone? Let's proceed to the next question. So I have marked this question. So at least there are 4 5 students in the live call. So to all of you, I'll just read this question, give you some time, probably 3 4 minutes, and after those 3 4 minutes, I will show you the solution. If you're able to solve this problem, I would like you guys to type the correct option only in the chat box. So let me just read the question for you guys. It states that in the following circuit, what is the output voltage when the input ABCD equals 1010? Assume logic 1 has a voltage of 2.5 volts and logic 0 has 0 volts, right? So here is a question, here's a figure, and you need to find out the output voltage. Has anyone done it? Yeah, good afternoon. You have any doubts? If you have solved the question, anyone in the audience, you can write the answer. Otherwise, I'll show the solution. So let me just show the solution. So yeah, no worries. So if you stay in the call up to the end, I'll just redo those first five problems. I can show those problems once again. No worries about that. But at the end, so let me just go through all the questions first, and at the end, I will definitely go uh, back over those problems. Uh, I hope that's fine with you. Okay, cheers. So we have this question. So let's just term these voltages as VA, VB, VC, VD, and the current that is going through this is IF. Anyone, what is the potential? What will be the potential here? What will be the voltage here at this point? It will be zero because of the virtual ground. Now let's do the nodal analysis. First of all, V out is simply equal to minus IF into RF, right? And my IF is equal to this current plus this current plus this current plus this, and that is equal to VA by R4 plus VB by R3 plus VC by R2 plus VD by R1. And as per the given question, VA equal to VC equal to 2.5, VB equal to VD equal to 0. So I can write it as VA by R4 plus VC by R2 I, and my V out is equal to minus times VA times RF by R4 plus VC times RF by R2. Plugging the values, it will be minus times VA 2.5, RF is 1 by R4 is 1, plus VC is 2.5, RF is 1, and R4 is 4. So this is nothing but 2 minus times 2.5 plus 0.625, and this is equal to minus 3.125. That is option C, which is the correct answer, right? So this was your question number 6. Now we can move forward to question number 7 of today's live session. This states that a 8-bit analog to digital converter is used over a span of 0 to 2.6 volt. So this is an analog to digital converter spanning over 0 to 2.56 volts. The binary representation of 1 volt signal is, so we need to find out the binary representation of 1 volt signal. So what we can do here is first find the resolution. So resolution will be equal to V range by 2 raised power n, and your V range is simply equal to your V high minus V low. V high is your 2.56 and V low is 0, so this is 2.56 volt. So this will be V range is 2.56 volt. Plugging it here, it will be 2.56 divided by 2 raised power n. N is 8, so this is 2.56 divided by 256. So this is your 0.01 volt. So your resolution is 0.01 volt. Now your output voltage, your output binary representation, decimal equivalent of output is equal to V of output by resolution. Your output, this should be input voltage, sorry, V input. So the input is 1 divided by the resolution is 0.01. So this is 100. So the decimal equivalent is 100. Now we need to find out the binary equivalent of 100. So this is 250, 0, 225, 0, 212, 1, 260, 230, 211. So this is 1 1. So this is 1 1 0 0 1 0 0 1 2 3 4 5 6 7. So this is 0 1 1 0 0 1 0 0. That is option 1. So this is your correct answer. So this was the solution for question number 7. Now move forward to question number 8. So question number 8 asks us, what is the output voltage of the circuit shown below? So we are given this circuit and we need to figure out the output voltage. So what we'll do here is we'll use the circuit analysis. Let's take up to this point. We can redraw this here. So this will be this is R, 2R, R, 2R, and R. This R and this R are in series, so it will give us 2R. Then we have 2R, 2R, R, 2R, R. Now this is in parallel, it will give us R. Then this R is in series with this R, so it will give us 2R. Then this R is in 2R with this is in parallel with this, it will give us R, and this R is in series with this, so ultimately we'll have 2R. So this entire thing is nothing but 2R, right? So my circuit would look like 2R, 2R, 2R. Now let's do analysis for this thing. Just a second. Let's term this point as Vx. This is at 0 due to virtual ground, and this is your output. And the current is going through this I. So let's do writing equations here. So Vx by 2R, that is this, plus Vx minus V by 2R, that is this, and this, plus Vx by V 2R is equal to 0. That implies Vx plus Vx minus V plus Vx is equal to 0. That implies phi Vx minus V is equal to 0. That implies Vx is equal to V by 3. Also, I is simply equal to this current that is flowing through here. I is simply equal to Vx by 2R. Vx is V by 3. It is V by 3 into 2R, that is V by 6R. And ultimately my B output is equal to minus I times R. So this is minus V by 6R minus V by 6R times R. So it is minus V by 6. So this is my answer, that is option C. Any doubts, any questions? So what we did here is I reduced this part to this. After that I did nodal analysis, called this point as Vx, wrote down this equation, and from that I got Vx equal to V by 3. Then the current flowing through here, that is Vx by 2R, is also flowing through here. So Vx by I is equal to Vx by 2R, I is equal to V by 3 into 2R, that is V by 6R, right? and then plug this value of I here. So V output is equal to minus IR. So it's V by 6 R times R. So it's minus V by 6. That is option C. Now I have this question for you guys to solve first, and then I'll show you the solution. So what is the output voltage of the circuit shown below? So the circuit is given, you need to find out the output voltage. So I'll just give you 5 minutes to solve it. So kindly do it and then show the solution. Anyone with the answer? So let me show the solution. Let's just call this point here as VZ, and this is simply but R2 R DAG. So your VZ is nothing but V reference times B1 by 2 plus B2 by 4 plus B3 by 8 plus B4 by 16. As per the given conditions, only B1, B3 is 1, rest of them are 0. So Vz is equal to V ref by B3 by 8, and your reference is 1, so it is 1 times 1 by 8. So Vz is equal to 1 by 8. Now Vz is given. Your output voltage is simply equal to the gain, that is, since it's converting to the non-inverting pin, so it is 1 plus Rf by R1 times Vz. So Rf is your 7, R1 is 1, so it is 1 plus 7 Vz, so it is 8 times 1 by 8. That implies V output is equal to 1 volt. Option B is the correct answer. So alternate method of solving it. So sometimes in exams, when you're solving multiple problems, it may not click to you guys that this was an R to R ladder and you applied the formula directly. You can apply the formula directly. So that times you can do the nodal analysis. So what we will do, this 2R and 2R are in parallel, so this will be R, and then we have R plus R, so this will be 2R. So my final circuit will look like 2R, two R, R, 2R, R, 2R. So this is your VZ. Just call this as Vx and this part as Vy. Now writing equations here. So this is Vx by 2R plus Vx minus 1 by 2R plus Vx minus Vy by R is equal to 0. So this is equal to, taking 2R as LCM. So this is Vx plus Vx minus 1 plus twice Vx minus 2 Vy equal to 0, implies 2V 4Vx. So implies 1x 1Vx 2Vx 4Vx minus 1 minus 2Vy equal to 0. That implies Vx is equal to 2Vy plus 1 by 4. Let's call this as equation 1. Now writing equations here at Vy. So it is Vy minus Vx by R plus Vy by 2R plus Vy minus Vz by R equal to 0. If you solve this thing, you get the final equation as 5Vy minus 2Vx minus 2Vz equal to 0. And if you plug the value of Vx here, you ultimately get Vy equal to 1 plus 4Vz by 8. Let's call this as 2. Now we'll solve for this point. So this is Vz minus Vy by R plus Vz by 2R equal to 0. Ultimately you will get out of this 3Vz equal to 2Vy. Plug the value of 2Vy here, so you'll get 3Vz 2 times 1 plus 1 4Vz by 8 2 1 2 4. So this is 3Vz is equal to 1 plus 4Vz by 4. So 1 plus 4Vz by 4. So this is equal to 4Vz equal to, so this is 3Vz by 4 1, yeah, 4Vz is equal to, let's redo this part. So this thing 2Vx by 2Vy, 2Vy is 1 plus 4Vz by 8, so 2 1s are 2 4s are, and then this is 2 12Vz. That implies this is That implies this is 12Vz equal to 1 plus 4Vz. That implies 8Vz is equal to 1. That implies Vz is equal to 1 by 8. And then we have the output is equal to Vz times 1 plus Rf by R1. So that is 1 by 8. 1 plus 7, that is 1. As you saw here also. Here. So this was question number 9. Now moving forward to question number 10 of today's live session. This is a question that states that find the binary output voltage for the input voltage V in equal to 4 volt and Vref equal to 6 volt. So this is again analog to digital converter. So we have Vref. Now let's mark these points. Let's term this as V7, this as V6, this as V5, this as V4, this as V3, this as V2, and this as V1. And now let's write V1. V1 is equal to Vref by 8. How did I arrive at this point? Simply using the voltage division, voltage divider. So this is V1. V1 is simply equal to Vref by total resistance, that is sum of R, that is 8, divided by R, multiplied by R. So R by 8R is simply 1 by 8. So this is Vref by 8. Similarly, V2 is equal to 2 Vref by 8. V3 is equal to 3 Vref by 8. V4 is equal to 4 Vref by 8. V V5 is equal to 5 times Vref by 8. V6 is equal to 6 times Vref by 8. And V7 equal to 7 times Vref by 8. Right. So this is your V7, V6, V5. These are the input here. All of them are comparators. So if the input at comparator is greater, the output will be 1, otherwise the output will be 0. So let's compute V7 first. So V7 is simply equal to 7 times Vref. My Vref is 6 volt. 6 by 8. 7 times 6 by 8 is equal to 42 by 8, and that is equal to 42 by 8 is equal to 5.25. So this will be 0 as V7 is less than V in. Now this is 6 times Vref by 8, so this is 6 into 6 by 8, so this is 4.5, again less than, so this will be 0. Then this is 5 into 6 by 8, so this is 30 by 8, so 30 by 8 is 3.25, so 3.25 is less than V in, so this will be 1. This will be 1. So since it's getting input to the priority encoder, I will not care about these values. Obviously they'll be less than V in, but since D5 is 1, that implies my output will be equal to 1, 0, 1, that is 5, decimal equivalent of 5. So as a result, my output will be 1, 0, 1. Now I have this question, so try to solve this question first and then I'll show the solution. It states that 8-bit analog to digital converter has a full-scale analog input of 5 volts. Its resolution is, so you need to find out the resolution of an analog to digital converter which has a full-scale input analog input of 5 volts. Has anyone done it? So let me show you the solution. So the resolution is simply equal to V range by 2 raised power n. Your range is 5 volt divided by 2 raised power n, and your n is 8. So this is 5 by 2 raised power 8. So this is 5 by 2 raised power 6. So this is equal to 0.019 volts. That is equal to 19 millivolts. Option A is the correct answer. Now, the question asks us the size of the priority encoder for a 3-bit flash ADC is. So, what is the size of the priority encoder required for 3-bit flash ADC? I think you just saw it. So, it is option C, 8 cross 3 here. So, this was your 8 cross 3. Now, we have a question which states that the maximum conversion time of a 8-bit successive analog to digital converter for a 2 MHz clock frequency is. So we need to find out the conversion time for a 8-bit successive approximation analog to digital converter for a 2 MHz clock. So we know that the conversion time of successive analog to digital converter is n times the time of the clock. Time of the clock is simply reciprocal of the frequency of the clock. So n is 8. This is 1 by 2 megahertz. So this is 8 into 1 by 2 into 10 to the power 6. So it is 4 by 10 raised to the power 6. So it is 4 into 10 raised to the power minus 6. So this is 4 microseconds. Option B. Now I have a question which states that a 4-bit R2R digital to analog converter using inverting op-amp has a reference of 5 ports. What is the analog output of for the input port 1010? Right. So if you look here, we saw this problem here. So this is simply this same problem. So here B4, B1, which is your MSB, B1 equal to B3 equal to 1, B2 equal to B4 equal to 0. My output V out is equal to minus RF by R1, B1 by 2 plus B2 by 4 plus B3 by 8 plus B4 by 16. So RF, let's assume RF and R are equal, which usually is the case. So this is minus times B1 by 1 by 2 plus 1 by 8, because B2 and B4 are 0. So this is minus, I'll take 8 common, so this is 4 plus 1, so it is minus 5 by 8, that is equal to, and here it is V reference, I forgot to write V reference, minus 5 times V reference. Reference is 5 volt, so this is 25 by 8, so this is minus 3.125 volts. That is option 1. So no, option 3. Then we have question number 15. It states that a 10-bit DAC converter is calibrated over the full range of 0 to 10 volts. If the input to DAC converter is 13A in hexadecimal, the output rounded off to 3 decimal places is. So my N is 10, my full scale range is 10 volts. So that implies my resolution is simply full scale range by 2 raised to power n minus 1. Full scale range is 10 volts divided by 2 raised to power 10 minus 1. So it's 10 by 1023, because 2 raised to power 10 is 1024. So this will be 1024 minus 1, that is 1023. Now 13A in decimal will be equal to 16 square times 1 plus 16 into 3 plus 10 into 16 raised to power 0. That implies this thing is equal to 314. If you do the maths, the calculation, you get this equal to 314 and this is in decimal. So my V output is equal to resolution times the decimal equivalent of the input. So resolution is 10 by 1023 times 314. So this is approximately equal to 3.069 volts. So here I will write 3.069 volts. Now I have a question: how many comparators are required for 3-bit flash type ADC? Just now you saw it. How many comparators? 1, 2, 3, 4, 5, 6, 7. 7 comparators. In general, if it was a 4-bit, it would be 2 raised to power 4 minus 1, that would be 15 comparators. Similarly, for 5-bit, it would have been 31 comparators, just like you can see in the options. Now we have the last question. This is also based on flash type ADC. Again, following the similar notion, we have to find out the output voltage for Vin equal to 10.13 and Vref equal to 16 volts, right? So here I'll just write V7. So this is V7, V6, V5, V4, V3, V2, and V1. So V7 is equal to V7 is equal to 7 times Vref by 8, V6 equal to 6 times Vref by 8, V5 equal to 5 times Vref by 8, V4 is equal to 4 times Vref by 8, V3 is equal to 3 times Vref by 8, V2 is equal to twice Vref by 8, V1 is equal to Vref by 8. So this is 7 into Vref is equal to 16 by 8. So this is 7 by 16 to 2, that is 14. 14 is greater than 10.13. So this will be 0. Then we have 6 into 16 by 8. So this is 12 volt. Again less than greater than 10.13. Then we have 5 into 16 by 8. That is 10 volt. So this will again be equal to 1. So 5 D5 is equal to 1, implies my output of priority encoder will be 1 0 1. So option B is the right answer. So these were some of the questions pertaining to the V-Kit material that we solved in today's live session. So if there are any doubts, please let me know. And also, as per the request of one of the students, I'll again briefly go over to problem 1 to 5. If there are any other questions, please let me know. Otherwise, that was all for the solution. I'm just revising first 5 problems. Otherwise, there will be no new problem solved. And if there are any doubts throughout this live session, you had any doubts, you can ask in the chat box. So, the first question of today's live session we had a 8-bit DAC having a step size of 25 millivolts, right? And we were required to find out the full scale output voltage. So this was a 8-bit DAC, that implies n is equal to 8 and step size was 25 millivolts, that is 0.025 volt. We know that step size is equal to full scale output voltage divided by 2 raised to power n minus 1. Full scale output voltage is equal to step size times 2 raised to power n minus 1. Step size was 0.025 multiplied by 2 raised to power 8 is 256 minus 1 is 255. So 255 multiplied by 0.025 will get the answer, that is 6.375 volts. This was a pretty straightforward question. The next question was an 8-bit DAC produces V out of 0.05 volt for digital input 1. What is the full scale output and resolution of DAC respectively? So given was my output voltage for input 1. So that simply means it is my step size. So I am moving only one step from 0 to 1. So that is simply my step size. So step size was 0.05 volt. That implies full scale output voltage is step size into 2 raised to power n minus 1. N is again 8. So 0.025 multiplied by 255 gives 12.75 as my full scale output voltage. Now resolution of a DAC is defined as step size divided by full scale output voltage. Step size I know, full scale output voltage are just found. So it is 0.025 divided by 12.75. that is 0.00392, and in terms of percentages it's 0.392%, right? So that is option B. Then my question number third was, if the resolution of a DAC converter is approximately 0.4% of its full scale range, then it is a what type of converter? So resolution is full scale output by 2 raised power n minus 1. It is equal to 0.4% of the full scale output voltage as given by the question. Then FSO stands for full scale output voltage. Then FSO by 2 raised power n minus 1 is equal to 0.4 by 100 into FSO. This full scale output voltage cancels on either both sides, and ultimately what I'm having here is 2 raised power n minus 1 is equal to 100 by 0.4. 100 by 0.4 is 250. So that implies 2 raised power n is equal to 251. So n is approximately equal to 8, because for n equal to 8 it's 256, and for n equal to 7 it's 128. So closer to this is n equal to 8. So it is a 8-bit converter. And then the question 4 was, this was simply a R to R ladder DAC. So we need to find out the output voltage for this case, where my B1 was 0, B2 was 1, B3 was 0, and B4 was 1. So B1 is my MSB and B4 is my LSB. So V out is for outward DAC is simply minus RF by R1 times Vref times B MSB by 2 plus B MSB minus 1 by 2 raised to 2, so on up to B LSB by 2 raised n. Here B1 is MSB and B4 is LSB. So ultimately my output voltage was equal to V out equal to minus RF by R1 times VRF times B1 by 2 plus B2 by 4 plus B3 by 8 plus B4 by 16. Plugging the values of B1 and B2, my output voltage is minus RF by R1 times Vref 1 by 4 plus 1 by 16. So that is minus 16 times, because R equal to R equal to R 1. So it is 4 plus 1 by 16. So it is minus 16 times 5 by 16. So it is minus 5 volt. And this question, that was, we need to find out the resolution of a 8-bit DAC having so the resolution of 8-bit DAC was 20 millivolts. We need to find out the output voltage. The resolution was 20 millivolt. Output voltage is simply given by resolution and decimal equivalent. Decimal equivalent of this thing is 128. So 128 multiplied by 0.02 is 2.56 volts. So are there any doubts? If there are any doubts in the live session, please let me know. Otherwise, we can close the live session, or maybe just wait for a couple of more minutes. Maybe some student might join. Let's wait for a couple of more minutes. Otherwise, after that, we'll close the session. If you want to leave, you can leave. Nothing new will be taught. This was the only thing that was taught for today. That was there to be taught for today's live session. If there are any doubts, queries, anything, you can ask me. Otherwise, session will be closed in a couple of minutes, unless some new students join and they want to ask some doubts and queries. So thank you guys for joining. If you have any other advice, question, query, suggestion, please let me know. Otherwise, we can see you next time. So yeah, one thing. So next week, I think my session might get postponed, most probably. So you'll receive an postponement email from the NPTEL. So most probably it will be on Tuesday, maybe Tuesday evening or Wednesday, either of the 2 days. You guys will be emailed about the postponement. So thank you for joining. Thank you guys. See you next time.